And next up, we have a new great talk about the NoSQL data modeling for front-end developers by Stanimira Vlaeva. Stanimira is a developer advocate at MongoDB. She's also Google developer expert for Angular and a part of the technical steering community for the native script. Her Twitter DMs are always open, so if you are interested in these kind of topics, do not hesitate to get in touch with her to talk about NoSQL, Angular, or native script. So please, everyone, let's welcome Stanimira. Hey, Stanimira, welcome. Ciao.
Hey Thomas, ciao.
How is it going? So, obligatory question, where are you connecting to us from?
I'm connecting from Sofia, Bulgaria.
Right. So, I see that you are going to tell us more about the data modeling and the MongoDB. So that's like a bit different topic from the Angular itself, but it's still very related because, of course, we always need to store our data somewhere, right?
Exactly, yeah, we're always working with data in our applications, so I hope this topic will be relevant and interesting to the audience.
100%. So please, let's not delay any further and let's learn more about that.
Thank you. All right, let's get started. Thank you for attending the data modeling talk. We will talk about NoSQL data modeling, or more specifically about data modeling for MongoDB. I'm a developer advocate for MongoDB, hence the topic today. So let's jump right into it. I don't have a funny story to tell or anything like that. Let's jump right into the definition for data modeling. Data modeling is the process of figuring out how to represent and store data in your system, usually using something called a database. But the more important question for you is, why should I care about that as an Angular developer or as a front end developer? Well, the answer is that depending on how you model your data, how you store it in the database, you will achieve better or worse performance. A good data model defined early on in the application development will lead you to better performance. It will improve your developer productivity, and it's also going to lead to lower costs of the overall solution. So if I convinced you to stay and watch, let's see what we're going to be talking about. First, we will define what is NoSQL or NoSQL, and where does MongoDB and document databases fit into this world. Then we will talk about how we can model relationships between our data in the system and how we can represent that in the database. We will discuss two main strategies for modeling relationships, which are embedding and referencing. We'll see which one should we use in which scenario. And then finally, we will talk about duplication and staleness, which are very inevitable when using a NoSQL database, and we will see how we should handle them. But first, let's start with traditional SQL databases. When using an SQL database, usually you split data across different tables. So we can have a products table with some information about these products, we can have a merchants table, and we can also have reviews table. Usually we connect data from these tables to return some result. And to do that, we use a language called SQL or SQL. So this is why they're called SQL databases. Then at some point in time, in the past 20 years, came the modern databases that kind of are successors of the SQL databases. And people started calling them NoSQL or NoSQL databases. But this term is super confusing because it's meant to mean not only SQL, but you can't guess that from looking at it, right? So another term that people started using is non-relational databases when talking about these modern solutions. But as we're gonna see throughout this talk, you can very successfully model relationships in MongoDB and in all other non-relational databases. So this is not a super accurate term as well. The term that I'm going to use is non-tabular because the databases that we're going to be talking about today don't use rigid tables the same way that SQL databases use them. they use a different data model. And we have four main types of non-tabular databases, depending on the data model that they use. First, we have document databases, which store data in documents. Then we have key value databases, which store data in key value pairs. We also have white column stores and graph databases. So today we will be focusing on document databases and more specifically on MongoDB, which is the leading document database. So the first term that we have to clarify naturally is what is a document. You're a JavaScript developer, so this looks super familiar. It looks like a JavaScript object. In fact, it is kind of a JSON object, and more specifically, MongoDB stores that as BSON or binary JSON, which introduces some additional types to the JSON specification. So we have field value pairs, as in every single object in JavaScript, and the value can be anything from a string to a number to binary data to an array of other things to also an array of objects. And here we're gonna call these objects nested documents or subdocuments or also embedded documents. So if you find this term or hear it somewhere, it's talking just about a nested object inside this document object. Then we can group documents together in something that we call collections. So we can have a products collection that contains different products. And the tricky part here is that we decide what to put in that collection. We're not really bound by the fields that every document has. So we don't have a strongly defined schema. Instead, we have a flexible schema. So in our products collection, we can have a book which has an author. We can also have a movie which has a revenue. And we can also have an album which has two additional fields, artist and label. But we can group all these together in the products collection because that may make sense for our application. So there are a few important notes here. First, some people call NoSQL databases schemaless, but this is not entirely true because every single document has its own schema. The schema is the collection of all the fields and their values. So every document has a schema. Instead, we have flexible schema because we can put whatever we want into collections. The other important note is that in some document databases, including MongoDB, you can add validation. So when you start developing your application, everything might be flexible because you can iterate super fast and that makes more sense for your application. But over time, you might decide that you want to lock down your schema and add validation. So you can say, I want every time someone inserts a new products document, this document to have a title of type string. I want it to have a price and it should be a number. And you can also add more specific validation rules similar to validators for forms in Angular. So two important notes here, we do have schemas, but they are flexible. And second, you can make that schema rigid, so you can add validation to it. All right, we have all that clarified. We know what is NoSQL now. We know what are document databases, what are documents. But how do we model relationships between these documents? Relationships are natural ways that our pieces of data relate to each other. And we're going to be working with some examples that you see definitely in your day-to-day application development. The most simple type of relationship is the one-to-one relationship. A book has a title, so it's a one-to-one relationship. And in this case, we are querying for books, so we're displaying books in our application. That is why we can simply put the title as a field inside the book document. So, one-to-one relationship, we choose one of the sites and put that as a field inside the document for the other side of the relationship. More complicated is the one-to-many relationship or one-to-one. So a book can have multiple reviews for that people leave for this book when they read it. This is why we say that a book is connected to many reviews. So how do we model that? How do we represent that with documents? We have two main ways to do it. The first one is by using embedding, and the second one is by using references. Let's see how these two look like. If we decide to embed on the one side of the relationship, this means that we have to put all the reviews in the book document as an array. Alright, that's clear. But we can also embed on the many side. So we can take every single review document and embed the book document inside it. So we are embedding on the many side. What about referencing? Well, the key to referencing is using IDs. So we have identifiers for our documents, and in this case, we have identifiers for our reviews. We have the review ID field in every review document. And then, because we're using referencing on the one side here, we also have an array of reviews in our book document, which contains the IDs for the reviews for this book. Later on, when we use the book document and we want to show some review, we can use a special operator called the $lookup operator in MongoDB to resolve information about this review, to connect these IDs to the actual documents and extract the information that we need. Of course, we also have referencing on the many side. And in this case, our book has an ID, and every single review document that lives separately from the book has a reference to this book. So later on, we can grab the book, we know its ID, and then we can query for the reviews for this book. All right, what are the pros and cons of these two? With embedding, everything is stored in a single document. That's why we use just a single query to retrieve all the data we need. Similarly, we only use a single operation to update and delete data. But we do have data duplication. As you saw, we can embed the book document in every single review document, but that means that we're gonna repeat a lot of information about this book in multiple places. So we have data duplication. And we might also have large documents. As you saw, we can embed every single review in the book, but if we end up having thousands of reviews, this is going to lead us to a very large document for our book. And referencing is really the other side of the same coin. So it's kind of the opposite benefits and the opposite disadvantages of using embedding. So we don't have any duplication. We have super small documents because we're working with these IDs everywhere, but we need to join data from multiple documents. And you can use the $lookup operator that I mentioned, or you can do it from your application. Just grab the book, then extract the ID from this book, and then send another query to the database to grab all the reviews for this book. And this operator that I keep mentioning does kind of the same under the hood, but it's more optimized because it's embedded by the database. It's implemented by the database. So you can see these are, again, the two sides of the same coin. But this doesn't really answer which one should I use to model the one-to-many relationship. And to answer this question, we need to take into account something else called the cardinality of the relationship. What this means is that we need to figure out if we're dealing with one-to-few, one-to-many, or one-to-zillions relationship. So if we're linking one item to just a few other items, to kind of many items, or to a very, very large number of items. And depending on this cardinality property of our relationship, we will have to use a different data model. Let's see how. Let's start from one-to-few. So typical for the one-to-few relationship is that the data that we're accessing usually should be accessed together. And it usually belongs just to one single system unit. An example can be a book and its genres. So a book has just a few genres, maybe 3 or 5 or even 10, but it's just a few. And we're usually going to show the genres in the context of the book. This is what I mean by access together. Similarly, a user can have just a few addresses, up to 10, but not more than that. and we're going to access them together. Like the address for this user doesn't really make sense out of the context of the user. We're not going to use it on its own. So because of these properties for this relationship, and because we're dealing just with a few items, we have to embed on the one side. The benefit is that the information is accessed together with a single query because everything is in one document. And the disadvantage is that the embedded documents aren't standalone entities. So if it's at some point in time we need to use the addresses on their own, like out of the context of the user, we will probably have to extract them into their own documents because it will make working with them and querying for them faster and more efficient. But usually this is not the case. That's why we choose to embed them in a single document. All right, One-to-few embed on the one side of the relationship. Let's cover the other extreme, One-to-Zillions. So zillions is just a fancy word for a very large number. And here in this specific case, it means a possibly very large numbers. So we may have just a few, but we may also have millions or even billions of connected items. Let's talk about an example. We write an article and put that on our blog. And because of some analytical reasons, we also want to track the visits or the views of our article that we wrote. So every time someone visits the page, we record that in a new document in the database. This user from this IP visited at this exact point in time. They stayed 6 minutes reading the article, and this is kind of the information that we're collecting. So we may end up having millions or even billions of page views. That's why we say that this is a one-to-zillions relationship. Similarly, a process that is running on our system is generating some log messages. And we may end up having quite a lot of log messages that are collected over time. So how do we deal with that? Well, if you think about it, you will arrive to the same conclusion. I'm just going to give you the answer straight away. But you have to use referencing on the many side of the relationship. So on the zillion side of this relationship. That way, we're not gonna risk exceeding the document size limit. In MongoDB, this document size limit is 16 megabytes. Let me give you another example for Firebase. I believe, like not an expert, but I believe it's just 1 megabyte. So NoSQL databases do have, or more specifically, document databases do have limits for their document size. And if you exceed this size, like not good things are gonna happen. But if you're also working with very large documents, you will also have probably performance problems. So if you end up reaching this kind of point in time and you see that you have very large documents, it's a time to take a step back and think about why is that data model leading me to a very large document size? How should I improve that? And in the case of One-to-Zillions, this can very often happen. So you should identify this relationship early on and use referencing on the many side. Let's see how this looks like in our article page views example. So our article has an ID, and every time someone visits it, we generate a new page view document that we save in the database, and we refer to this article by its ID. That way, we're not exceeding the document size limit and we're safe. All right, we covered both extremes, but what do we do in the middle case when we have a regular one-to-many relationship? And here I don't have a recipe for you, but I can prompt you to ask yourself another question before modeling. And the question is, are you dealing with two separate logical system units, or are you dealing with just one? In our example with books and genres, we can ask ourselves, are we always going to access the genres in the context of the books, or can the genres also be used in the system, or may we have that requirement come to us to implement as using the genres on their own? So maybe to display a page with all genres, or have a genres detail page for every single genre that we have. So are we gonna need the genres on their own? And if the answer is yes, we're dealing with two different units, books and genres, then it's better to split them into two different collections and use referencing to connect them to model this relationship. If we're dealing just with one logical unit, we're gonna need only the books, and the genres are just an information about the book. They're not a thing on their own. Then we should embed on the more often queried side. And in our example, this should be the book. But in the other case, if we're dealing just with genres in our system and the books are kind of information about our genres, maybe it's good to embed on the genre side. But like, this is a really simple example. If we have a lot of books and we want to embed them in the genres document, this will lead to a very large number of documents that are embedded. So maybe it's still good to use referencing. But if we have the other example that I started with, a book, and we're looking for books only, and the genres are information connected to the books, then we should embed the genres in the book, because we're dealing with few genres, or even if it's hundreds, it's still fine. We can use embedding because we're going to access these two on their own. And if the answer is I'm not sure if I'm gonna need to separate these later, then maybe separate them from the start. Unless you're looking for a proof of concept and you're not afraid to migrate and separate them later. All right, let's see some more real-worldy example and how we can use embedding and referencing together. In this example here, I have a system which lists meeting rooms, and a user can book a meeting room. And every time a user books a meeting room, a new booking document is created. And this booking document has references both to the meeting room and to the user. Then at some point of time, I have identified that the query for listing bookings for a specific date is super critical for my application. Maybe it's a calendar application, because in the calendar application, people make this query every few seconds. For every single day, we need to find the bookings, and it's executed very often, and it's critical for my application to make it fast. But we might have a problem with referencing, because when I execute this query, list all bookings, first I'm grabbing all the booking documents, and then because I also want to display some information about the room and about the user, not their IDs, I have to grab the ID and find the corresponding room document and get the necessary information out of it. Then I have to do the same for the user. And then I'm gonna have to repeat that for all the booking documents that I have. And this works fine, but we're using one query to get the bookings, and then we're using two double lookup operators. You can think a bit of it like two additional queries to grab the room and the user information. And this can lead to performance problems, because we are performing 3 times the the query for displaying just a single result. And if we are performing this query really often, we might try to optimize it. The good thing about referencing is that we don't have duplication and we have super small documents, but again, we need to use $2 lookups. So how do we optimize that? And you may say, okay, I know about embedding, let's try to embed it. So instead of having separate documents for rooms and users, we're gonna embed the room inside the booking document and the user document inside the booking document as well. That way, all the information is in one place. We only need just one single query to grab all the bookings, and we have the information about the room and the user that we need. The disadvantage is that we have a fairly large document. We also have lots of data duplication, because the name, the capacity, the floor, the setup for the room is duplicated across every single booking document, and it's also present in the original room document. And most importantly, we have tons of unnecessary data. For displaying the booking in our calendar application, we only need to display the name of the room and the name of the user who made that booking. We don't need all that extra information that we are embedding. So how do we solve that? Well, we can embed just the information that we need using something called the extended reference pattern. So we still have references because we're keeping the IDs for the room and user in the booking documents, but we are extending this with some additional embedded information. Together with the ID, we are also keeping the name for the room and the user. And this will work super great because we're going to use just a single query to get all the information. We're going to have really small documents. We won't have any unnecessary data because we have only the minimal amount of needed information. But as you may notice, there is still some data duplication. We're duplicating the name of the room and the name of the user across all the booking documents and all the original room and user documents. So if someone changes the name of the room in the original document, what should we do? Should we update the bookings as well? Well, we are not sure. But this is caused by duplication. But why should we care about duplication? Like this works very well and super performant for our use case. So should we deal with duplication at all? And I can just tell you that don't be afraid to duplicate data in this use case and in many real world application use cases. Duplicating data is fine. It leads to a more performant system. It makes your application faster and your queries more optimized. So don't be afraid to duplicate data. Data that is accessed together should be stored together. So just follow this advice and don't think about duplication. But I know that you're developers, you can't just forget that there is this caveat here. So all right, let's think a bit more about duplication, and I'm gonna take you through two different scenarios, which are kind of the general scenarios for dealing with duplication. The first scenario is when we're dealing with dynamic objects and historical data. Let me give you another example. So we have a system for ordering products. Whenever a user orders something, their address is copied in the order document as the shipment address. And here the tricky part is that if we were to use references and the user were to change their address, we will also incidentally update the shipment address for the order. And this is not the desired behavior because we actually need this piece of information to be the same for every single order that the user makes. Not the same, but it should be a different address. Like when they make the order, this should be the address that is there, and it should be remain the same unless the user goes and changes it explicitly. So in these types of use cases, we actually need to use duplication to ensure that we are keeping the right information in the right place. But there are all the other scenarios out there that lead to duplication that should be managed. And let me just tell you that this will mean writing more application code and performing more write operations, which may lead to some performance slowdown. And it will also take you more time to manage. So before duplicating, you have to weigh the benefits versus the efforts of managing this data duplication. And it usually may mean that we may really easily manage this duplication, so it's worth to do it. But yeah, just think about it before doing it. And when I say managing duplication, what I really mean is managing stale information. Stale information is information that doesn't reflect reality anymore. In the examples that we're looking at, staleness is caused by duplication. It can be caused by other things, but we'll just discuss the duplicated stale information. And staleness is inevitable if we are dealing with duplication. The actual question that we should answer is, for how long can stale data be tolerated? Let's talk in examples again. We saw the meeting rooms and the bookings. So if someone changes the name of the meeting room, Should we update the booking information for old bookings? Maybe we shouldn't update it at all. Like, we don't care about the meeting room name in some booking that's already in the past. Maybe we should just leave it as is and deal with it if someone by some reason requests the old meeting information. So in this case, we don't need to manage stale data at all. But there are other examples. If we're dealing with, let's say, flight delays, then stale data can't really be tolerated. Like flight delays are very time sensitive, so we need to deal with stale data as soon as possible. And this will really depend on your application use case. You have to identify this time limit that you have to update stale data. And once you have identified it, you should manage the stale data with batch updates. So you shouldn't perform update every time something changes. You should batch these changes and perform an update to the related documents. Let's see a code example. In MongoDB, there is this feature called change streams, which allow you to subscribe a change in a collection of documents. In this use case, we are subscribing to the collection users, and we're using a pipeline operator to match all the updates that are performed on this collection. Then we are creating a change stream with collection.watch, and every time a change comes, we're going to be notified through that change stream. Of course, we can deal with that change by passing in a callback, and in this callback, well, it really depends on us how we're going to deal with this change. And here I recommend to just accumulate the changes over time and then perform a batch update to all the related documents. And again, this should really depend on your use case. And you should figure out for how long can you tolerate stale data. And then you should use change streams to deal with that stale data. If you want to see a more full example that uses Node.js, take a look at this link tutorial. It's great. All right, let's summarize. If there is one key takeaway from this presentation, it's that the application use cases should drive data modeling. It shouldn't be the other way around. So if you are a traditional SQL database developer, you are probably used to splitting data across tables, normalizing it, and doing whatever, and then starting to create your application and trying to connect that to the database. In document databases and in general in the NoSQL world, it's the other way around. You should model your data and how it's stored in the database based on your application use case. And we saw many examples how you do that. So how do you get started? You're starting with a new application and you decide to think about the data model like for the first time or uh, in a new way, in the NoSQL way. So first, identify which are the logical units that you're going to be dealing with and what are the relationships between them. One-to-one, one-to-many, many-to-many. We didn't discuss many-to-many today, but you can easily find information how it's modeled, and it's very similar to one-to-many, let's say that. Then you should probably identify which queries are most important and which queries should be optimized. And depending on which queries are more often used, you can adapt your data model as well. And here I want to say also that data modeling is an iterative process. So it's not something that you do at the start and then forget about it. Your application will change over time. You're going to introduce new features. You're going to identify performance problems. So you need to update your data model as well to match these new features and these upcoming changes. So make sure to think about data modeling even if when you're developing your application and you're in the different stages of the life cycle of this application. All right, let's summarize with a few points. First, I'm going to repeat that model data based on your use cases, not the other way around. Second, take cardinality into account when modeling one-to-many relationships, because this is going to lead you to a different data model. Third, keep the logical units in different collections so you can easily access them. And finally, manage duplication and more specifically staleness with batch updates and change streams in MongoDB. Right, thank you for joining. The first link over here is the link to the slides. And here I have also linked a few really useful resources if you want to learn more about data modeling. We have a whole free course on MongoDB University. It's a bunch of videos and it's very well done. So it's like a whole university course. You can follow it. It's maybe 6 or 7 hours long. So it takes a while to complete it. It has also a lot of exercises. So if you're kind of a theory geek, it's very nice. Also, we have a bunch of blog post series, so make sure to check them out if reading is your thing. And finally, we also have the tutorial for using change streams and triggers, which are a feature that is provided by MongoDB Atlas for handling changes that are coming to your application. And thank you again for joining.
Hey, Stanimira, thank you very much for a very informative talk. I have to say, like, this amount of like high quality official free information sounds really, really good when you try to like learn a new technology and that it's like coming from the official source so that the quality and like being correct is guaranteed. I think that's really, really cool and it's not like the standard with many technologies. So that's very nice.
Thank you.
Folks, please do not forget and hesitate to ask questions in the chat. It can be in the chat, it can be the Q&A section. We are going to find it so we can relay them to Stanimira. And then besides that, let's start a bit more light-hearted. So I really like the use of the meme in your talk. So we have the embedding and we have the referencing and we have the red and the blue pill. So which one is which one in your opinion?
I'm not sure. Maybe embedding is like the pill that gives you the new point of view because you're not used to embedding everything in a single document, and now you're told that this is okay and you can duplicate data. So it's kind of
Sounds
the
perfect.
yeah.
Yeah, definitely, it's true. Like as you said, like we should not be really afraid to like duplicate data because, as you pointed out, in like a couple of use cases, exactly what we want when we want to preserve the history and stuff like that. And I have to say, like that, the longer I do the like software development, I would say that similar concept can be also applied to the code, right? Because if the people take like this, do not repeat yourself to the total extremes, everything becomes coupled to everything, and if you want to change like small part of your application, suddenly oh my god, I'm impacting all these things. So and this
Yeah.
really is basically the same concept as you described like with the data modeling. So I think that's a very good lesson there, which can be then used not just like for the managing of the data models but in the software engineering itself. So thank you for that.
Yeah, definitely. People can go crazy trying not to repeat themselves and put everything in one place, man, use many abstractions and just try to follow this kind of guidance that they learned early on because it's what everyone does. But we should kind of approach that critically and maybe not do it every time.
Exactly, like yeah, I speak from my heart because yeah, like if also when you work like in large organizations, then you kind of see like you need to evolve stuff, as you said, like the data model will evolve over the time, the applications will
Yeah.
evolve over the time, and this kind of duplication also gives us isolation. So that means we can change some things without affecting everything else, which can be very beneficial in these kind of situations. So, folks, nothing yet. All right. So then other thing which I like to ask based on your presentation, which stick out to me, is that you mentioned that it is possible to make the schema rigid. So that means like you have some guarantees about how your data model is look like once you are in more like stable part of development of your application. I would like to ask like what kind of support are we getting there as a developers? Like if there is like some official library, or what's the approach to do that? Is it like on the level of the database itself? Is it some kind of validation in the application? How is this done?
Yes, that's a good question. So many people who have used MongoDB in the past, myself included, are used to using Mongoose, which is a community supported library. Like Mongoose is great, but the problem with it is that it applies this validation on the application level. So if you try to actually insert something into the database, it's not gonna stop you, like if you're directly inserting stuff in the database. And at some point in time, the Node.js driver for MongoDB, which is the officially supported driver, also introduced validation. Or maybe I should start from the back. We introduced validation at the database level. So you can actually use validation through this Node.js driver, and this validation will be enforced at the database level. So doesn't matter from what application you're connecting from. So you can be a mobile application or a Node.js server. All that you will have the same validation rules which were defined for you.
This
And for
sounds
that,
very
we're
good.
using JSON schemas. So if you ever use schematics, you're very familiar with JSON schemas, and it's also the same thing that the Angular COI configuration file uses. So yeah, that's what can be used.
Yeah, this sounds very good because, of course, like most projects start like, okay, there's a single DB, there is a single application, but over time, maybe we have like a native client and the phone, or maybe connecting from some other application or what have you. So it's very cool to hear that it's actually possible to enforce this kind of rules, like in the interface of the database itself, so that that way we know we are safe. Like, and now no like data which has malformed can enter our system. So that's pretty cool. Besides that, I would also like to ask, like, what are some other resources to find out more about data modeling? So, like, of course, you mentioned like all these official ones for like the MongoDB itself, but all these like cool examples which you showed us, like in terms of like how big it is and more about that, maybe.
Yeah, there are many examples depending on what you're looking for. So, for example, if you're a Firebase developer or using Firebase, there are great talks on YouTube. Just search for Firebase data modeling, and it will come up. This talk from Google I/O that I'm talking about. And in general, there's just a lot of information about data modeling scattered around. But if you watch this MongoDB University course, it talks about data modeling patterns, which are super useful regardless of the database that you're using. They're kind of design patterns that appear over time, and in this case, it's related to the database. But you will see that something like the extended reference pattern, or the computed pattern, or the bucket pattern are things that you can also apply in your application code, and as well as your database as well.
Sounds great. So, with that being said, so folks, if you still have some questions, feel free to post them in the chat. I think Stanimira will hang out like for a couple of more minutes after the talk. So, if you want
Sure.
to interact, then do not hesitate. And I would just like to thank you again for an amazing talk. We learned a lot. It's always nice to also like expand our view and even like to connect it to other parts of like the software engineering. So that was really amazing. And hopefully we can see you at the future edition of Angular Day. So thank you very much, Stanimira. See you next time.
Definitely. Thank you as well.